our invitation and for giving a lecture on smart materials, an introduction to every one of us in the Institute of Engineers, Ranipet local center. In fact, I wanted to introduce Capt.Dr.A. Suresh Babu. He is the professor, Department of Manufacturing Engineering, College of Engineering, Guindy, Anna University, Chennai. I am a life member of Quality Certificate Forum of India, QCFI, Indian Society of Technical Education, ISTE, Additive Manufacturing Society of India, Material Research Society of India, and Senior Life Member of Operation Research Society of India. He is an external expert for Technical Evaluation Committee of CIPET Chennai. He is also an evaluator of funding under University Grants Commission, UGC, research schemes. He is a recipient of Advanced Material Award for the contribution in the field of Advanced Material Science and Technology from International Association of Advanced Material, IAAM, Sweden, in the year 2023, and citation for high impact research publication in the year 2016-17 by Ieirlc Endowment. Also, he received Professor A.S. Raju Memorial Award, awarded by Professor A.S. Raju Endowment 2014 for academic contribution. Received commendation for the year 2022 and also 2024 from Deputy Director General of NCC PNP Directorate for National Cadet Corps for the contribution to the community development activities. His research areas of interest include composite materials, additive manufacturing, machining, joining, and optimization of manufacturing processes. Such a highly qualified and experienced and well-developed person today is our faculty for the today's session. And on behalf of Institute of Engineers, India, Ranipet Local Center, I am very happy to introduce him and request him and extending a warm welcome to Ranipet Local Center for the today's lecture session. Now I request Capt.Dr.A. Suresh Babu to take over and explain the smart material to all of us. Thank you, sir. Thank you for accepting our invitation and joining us today. Thank you so much.
Thank you, Satyav. Thank you for a nice introduction. Just I share my presentation. I will start. Is it visible, sir?
Yes, you are.
Yeah. Thank you. Thank you for the nice introduction. I have long association with the Institution of Engineers. In fact, we have conducted some of the programs in our department, so the production engineering group. As all of you know, it's a very well-known institution. It is of 230 years old of academic reputation, College of Engineering, Guindy, from where I am from the Department of Manufacturing Engineering. It is having some 60 years reputation in the field of delivering manufacturing education. So in fact, this presentation is prepared for training teachers at Teachers Training Institute. It is a 1.5 hour lecture. I hope I will be, as it is requested, it has been completed maybe another 50 minutes. At the latest 8 o'clock, I will be trying to complete the presentation. So this, the thirst to search for the materials, advancement, I started in the year 2002 when I started my career in research. I started in the field of composite materials, and when I asked to give a lecture at PhD Tech for functional material, I started searching of development of materials, where I could landed up with functional materials for aerospace. In addition to that, I could see that there are materials which has been developed for long years, but it has not been explored for us. For us, as in our department, I wanted to open a venue for this. So with that background, I have collected some of the materials. I wanted to share what the preliminary knowledge I gained from these collections. So I hope that will induce some of interest on you for further proceedings as research or some of other proceedings for you, even for academic. Usually I start with what is the demand. All business people, they wanted to know what is the demand for any of the advancement which has been happened. So this is the background on which this growth of smart materials happened in worldwide. If we see the growth rate, in 2022 it was 58, and in 2023 it is 65.3, and it is estimated to reach of 172 to 30 and maybe $200 billion in 2032. That was a estimation, maybe slightly logged in the CAGR report, which has been 13.5, which has been estimated in 2017 to 2025. But because of the pandemic, it was 6.5. Maybe it has been regained its momentum, and because of health sector is very much growing after pandemic. All these materials which will gain importance in the applications of health sector, particularly, and other sectors also, as it has been mentioned here. Different regions of world which is having the demand of this very great demand at North America, and it have seen that India also now is gaining momentum to in the materials field, starting industries towards this electronic side. Maybe these materials will also gain here its importance in the establishing the industrial sectors. Okay. So the other side might we have seen piezoelectric to electrostatic material. That is what we are going to discuss when it was evolved, and what are the background or what applications for which it has been evolved. Not too in depth at the surface level discussions we will have, so that you can go in depth whatever the applications in which you wanted to orient. So this is the content of presentations which has been planned. We will start with what is smart materials, what is a system when it is employed for the applications, and the classification of different smart materials, and we will conclude with. See, these are some of the texts you can refer. I referred for this presentation, as well as can. If you're interested, you can note down and you can proceed with your further studies. So a smart material is having importance in the sense that when any external force which has been applied there, what is its reaction in a smart way. So that is what a material can be classified into a smart material. When it is part of a system, it might have a control system in which might employ your control aspects of this. Even if it is material is, if it is in random order, you will not be able to do that. So, like you may look at the analogy of people, human being in a system. So, what is the need? This I have felt a need where usually engineers look at the materials when it is tested. If you test overall the three dimensional volume of the materials, we always look at a traditional way of look at the material. It should be uniform throughout the breadth and width of the material. When in the recent days applications in which we had given some requirements which might been felt that the traditional approach might not be useful for evaluating the materials, in which every materials in the natural sense, if we see that it will exhibit different characteristics of different situations. There, what is the force which has been applied at what the area of that material in which it has been applied, or what depth in which it has been applied. So this is an example in which you can see that the disc in a spinal cord, if it is to be replaced, what kind of material which will be useful for that? It is simple homogeneous material. If you put in inbitable, it might not work for you as it has been naturally. It need to be replaced for the functional aspects to be fulfilled for the human being to restore original conditions. So that is what the need. I feel that the two contradictory properties of that need to be solved. Like here, as it is mentioned as strength and flexibility to be maintained. There different structural aspects of these materials which can be obtained there. So another group of materials we can see functional materials. Maybe you can consider vice versa, the functional as well as smart aspects into that. As far as the structure is concerned, you can see biological point of view might have a lot of ideas one can get what is to be required when a material to be behave like natural reactants for the things which has been environment changes or any other post changes. If even if it is created by man. So whether it is thermal aspects, as it has mentioned, the heating, or any temperature for which it has to be responded, or if any changes, if it is occurred, whether they are ready to themselves or protecting themselves. Like that, we have seen number of examples these days in civil engineering structures. Some of these aspects might have been placed already there in the applications. Even any common man can understand the requirement for all these things. So the monitoring and optimization is part of the system to adapt to any situations. So integrated design is a requirement for creating that kind of adaptability in the materials to be placed in applications. So that is what the biological system which exhibited naturally. So when what discipline where which we can classify this as materials are originally classified with the civil and mechanical. No, now we need to have integrated many disciplinary. It may be of isolated systems which can be connected with as multidisciplinary, or if you go with interdisciplinary by mingling any of two engineering field, like here which is mentioned, the mechatronics. Or nowadays we had another terminology called transdisciplinary. When you have this kind of interdisciplinary system, if it is to be applied in practical applications, you have to go for transdisciplinary informations, inputs, particularly. You can see that medical and engineering, this kind of transdisciplinary which is required. So that's what our university is also now having MOU with law university as well as medical university to have such kind of application oriented research to be taken forward. So the stimuli in the sense and the smart materials might have three components. We are going to see in the next slide: sensing, actuation, and control. And it may be of any of the applications, maybe for the detection or diagnostic or corrective or controlling, heating or damage arresting, kind of applications in which we can use this. As it has mentioned, it has been connected by data transmission and instructions. As it is very similar to biological system, particularly in a human. We have these sensors, controls, and actuators with data transmission, data instructions. So you can look at the analogy. We have in-depth discussion on these aspects of all these kind of systems. You can refer the paper which is mentioned. So acquisition, it is very similar to what is a tactile sensing, which has been there by having our finger touch any materials to feel that. After that, the data which has been taken forward and has been transmitted to the brain. There is a control unit where it has been processed and it has been identified that what has been touched. If it is hot, the brain will tell action to you that you have to withdraw the finger very immediately. So that is what which has been there with data acquisition and data transmission, command and control unit, data instructions and action devices, which has been very similar to tactile sensing, sensory nerves, and brain, as well as motor nerves, muscles, which has been acted upon at the end as actuators there to withdraw your hand from the hot object there. So that is what the order which has been made by the control unit through the motor nerves. So the same system, if it is implemented, if it is there in the applications, it will be very much useful. That is what which has been identified. So there are materials which are identified and classified under smart materials. Piezoelectric, electrostrictive materials, magnetostrictive materials, rheological materials, thermoresponsive, fluorescences, biomimetic materials, smart gel, in which the reaction of the materials are maybe having dynamic or static aspects of that, with which the materials can be further classified. These materials can be grouped into two. But I put it into one single basket because it is a very introduction lecture in which I don't need of having that kind of division of materials. So piezoelectric effect, it was discovered by Pierre and Jacques in 1880 when the material of like quartz, which has been having pressed some electricity which has been exhibited. Similar wise, it has been vice versa. It has been worked upon that. When it is applied with electricity, it might have been changed in its values. So it is very common to ceramics also. Some of the ceramics in which will be able to polarize, so you can go with the PCT. The example which has been given here, zirconate, titanate. Likewise, barium also can act upon. So there are a number of elements. We are going to see that how many number of elements which will exhibit these kind of characteristics. So further, if you go with the principle, are almost same with piezoelectric, with where a little bit variation of electrostrictions. The materials are a little bit different. Magnetostrictive effect, which may align with the electrostriction, but the force which has been used here, the energy used is different. And the third one is piezoresistive effect. It is not gained momentum as has been there, the magnetostrictive or piezoelectric or electrostriction. And because of the applications are not the energy transmission with which we will not be able to have some kind of effect. So maybe in future, like magnetostriction, how it gained importance after the invention of room temperature, at which it can be able to go for an applications with some kind of materials invention. So likewise, maybe people will work on piezoresistive also. So piezoelectric materials, just we see when we apply some force, it will so kind of movements. So how, what is the principle behind? We will see in a video.
Electronic stethoscopes can convert sound waves to electrical signals, which enable them to listen, record, and play back sound waves coming from the body. One of the most popular ways used to convert sound signal to electrical signal is
Sir,
using
video was not
piezoelectric material.
Sorry to disturb.
The special property of piezoelectric material is that when external stress
The video is not playing, sir.
the material,
Sorry to interrupt.
can generate voltage. Let's take a look.
Video play agla, sir.
Video இல்லையா? Maybe
ஆமா.
time நினைக்கிறேன் உங்க இதுல.
Okay, okay, sir. அது ஒரே ஒரு ஸ்லைட் தான் சார் தெரியுது வீடியோ.
Electronic stethoscopes can
Now?
convert sound waves to electrical
No, sir.
signals, which enable
Still it's not coming, sir.
Okay, now one second. Maybe I have to go to the. I have to stop sharing your presentation. Then I have to go to.
Yeah, yes, sir. Yes, sir. Yes, sir.
It is a problem of Zoom actually.
them to listen,
Now?
record, and play back sound
Now is it okay?
It's playing, sir. Playing, sir.
waves coming from the body. One of the most popular ways used to convert sound signal to electronic stethoscopes can convert sound waves to electrical signals, which enable them to listen, record, and play back sound waves coming from the body. One of the most popular ways used to convert sound signal to electrical signal is using a piezoelectric material. The special property of piezoelectric material is that when external stress is applied across the material, it can generate voltage. Let's take a look at how these materials are able to exhibit this unique property. Consider this structure of a silicon dioxide material, popularly known as quartz crystal. When we take a look at this structure from a specific angle, we see it has a hexagonal shape. The big question is why the piezoelectric material produces an EMF across it when you apply a force. To get the answer for this question, first, we need to understand a concept called electronegativity. Here, the oxygen and silicon atoms share one electron. Due to the smaller size of oxygen atoms, the shared electron is closer to the oxygen's nucleus, so oxygen will exert more force on the electron than silicon. As a result, oxygen is more electronegative than silicon and will have a slight negative charge. This also means the silicon atom will have a slight positive charge. So the oxygen and silicon atom together constitute a dipole. In the quartz crystal, these dipoles are arranged such that the center of charges of the negative and positive atoms coincide. Now what will happen to the center of charge if we apply a compressive force across the molecules? The center of charges do not coincide anymore, and there will be a charge separation. This is called polarization. This also means an electric field will be created between the net positive and negative charging. This leads to generation of a small voltage across it. The quartz structure consists of multiple similar hexagons connected in series, which lack a center of symmetry. So now, if we apply a compressive force across the entire material, the individual charge separations of these hexagons will add up to generate a voltage across the material. Let's replace these charge pairs with small cells. It is clear that if we have more cells in the series or thickness of the material is more will be the net voltage developed. Now, what do you think will happen if a voltage is applied across the material? The special characteristics of piezoelectricity is that it is reversible. If a voltage is applied across the material, the positive and negative charges of the material will experience forces in the opposite directions, and the hexagon will get stretched. Similarly, if the polarity of the voltage is reversed, the hexagon will get compressed. This stress or strain is transferred across the material, resulting in a net compression or expansion of the material. Now, let's study the working of an electronic stethoscope. The electronic stethoscope has a very thin diaphragm connected to the piezoelectric material. When the sound waves hit the diaphragm, it oscillates, making compressions or expansions in the piezoelectric material. This produces voltage across the material proportional to the amount of deflection. The voltage is then transferred to an amplifier and filter circuit to get the desired output. We connect the piezo material to a foam spacer and a steel plate to enhance the vibrations, which in turn results in generating more voltage. Thank you for watching the video. See you next time.
The presentation visible? Nila?
Yes, sir. Yes, sir.
Yes, sir.
The side, one participant window is there. Can it be closed?
Participant windows not, sir.
For me, it has been there.
Can you minimize it, sir?
I will see that. That presentation is visible to you?
Yes, sir. Presentation is visible, sir. Please.
Okay. Is it moving now?
Yes, sir.
Okay. So as we have seen, the reverse effect is also there. Okay. So I don't want to spend a lot of time on this because it is a very long presentation. So the applications, as we have seen, the health sector, in which as stethoscope, you might have seen these lighter and which has been used, gas lighters, which has been used in our home. It is also having the similar arrangement there. The piezoelectric is there, where you can convert the mechanical movement of that will hit. This makes now with the fuel which has been presented there, the spark which can be come out as a flame. So that is what the arrangement is. A very small examples just for the understanding. Likewise, we can go a number of examples with which these materials are used. So particularly when you go for energy harvesting, in which you might have these kind of materials can be employed in machineries, where different structure, as it has been mentioned here, with aligned frequency or non-aligned with we have structures like cantilever with zigzag or unimorph, bimorph, or if you wanted non-aligned structures like simple and stacks can also be used. These are all structures where one can employ for part of machineries where you might have harvesting energy from the movement of the equipments also. Actuators, the linear motors, which has been functioned based on this by having this morph arrangement. You can have walking state kind of arrangement with the piezoelectric movement by having expansion and contractions of bimorph materials, in which passive and active materials presence may make the displacement as it has been shown here, so that you can have the movement of materials. Likewise, the actuations can also be done. So there were large number of applications possible with these kind of materials. We can explore if one have a research mind on these materials. So these are all the naturally available materials. Whether you can see that it is in most of the materials which is very familiar to you. Whether it is in a bone or a salt, or can have done the enamel of the tooth, sugar cap, in which even in DNA might have the materials which can be. So if you want to have how the biosensors in which it has been explored, can refer this paper. This is a very good paper by Tomini. And other applications, you can see that in these days we might have seen the natural eye movement of robots, which has been done by this arrangement. And in your cell phone might have seen correction system which has been employed by having these actuators, motors on the other side, so that you will not have you will not have earlier error photographs can be corrected automatically. Auto corrections can be possible there, or pumps in a huge little bit higher level systems. You can use it for an electrical pumps. On the bio side, we have very large amount of applications for these kind of materials. This is one magazines in which you could have what are all the manufacturing processes through which you'll be able to go with the kind of materials we are going to see in the coming slides. It is just for the sake of sharing what kind of materials has been available in the health sector, what kind of processes can be applied for having fabricating that, and already some of them we are using our smartwatches like that, in which how these materials, these processes were employed to try to implement in the applications. So this is one barium titanate. As I told, barium titanate, one of the ceramics which can be used. Likewise, zinc oxide. So there are different property level with which we go for an applications like whether it is a stable or compatibility with bio requirements or electric laws which has been happened there. So based on the arrangement of the material which has been used, whether it is in a polymer or nano level materials like molybdenum sulfide, or can have biomoleculars like glycine or diphenylalanine or collagen, which has been taken from the mammals, can also be exhibited with kind of characteristics can be applied with the health sectors. So this is a large scope in which these materials, how it can be coming into the applications of health sectors. It is one can easily understand the application, because we are all the users of outcome of these processes, how these materials converted and bring into the applications for a human being. Again, the video is not coming, na?
No, sir, video is not coming, sir.
Okay. Now we'll be able to see the
Visible.
screen, video screen.
Yes, sir, visible, sir.
Yes, video is
Not
coming.
playing, but. Okay, sir. The video is not playing, sir. It is in pause.
It is not playing. Is it playing or not?
It is playing
It
in
is
the
playing, sir, but it is playing, but there is no voice in this video.
Okay. Some messages come.
Yes.
Okay, able to recognize this now. What is what I wanted to communicate through this video is so there are wearable devices which has been developed by Georgia Tech University. Okay. That has been now witnessed in our applications in the health sector. How one can appreciate through your smartwatches how it has been used okay, for having measuring the required measures for monitoring the health conditions of one. Okay, so that is what the message I wanted to communicate through that video. Okay.
Sir,
That-
sorry to interrupt, sir. Actually, questions we will keep in the end, but one small thing alone I will ask, sir. Whatever you have shown in this piezoelectric material, no, sir, it is all smaller devices or instruments only, no, sir? Anywhere
as I have shown now that pump.
yeah.
Mechanical devices are also used. You can see that electrostatic applications. It can be employed in little bit higher level, where you can see that ultrasonic welding.
Okay.
That is one kind of application. Ultrasonic machining or welding, where they can employ this.
Okay. Yes.
This is a little bit lesser when you go for higher applications. Better you have to go for electrostiction and magnetostictions.
Okay. Sir.
Is it okay?
Yes, sir. Okay, sir.
Okay. So this is the research potential. If any academician is there, we can go with what is a application for different other than the sectors which is mentioned here also. So this is another material. The simple change with piezoelectric is it's coming into piezoelectric, in which electrostatic is classifications based on what is the displacement which has been produced, the square of that. Whether it has not been having the restriction of the direction of displacements which has been happened there. So that is the difference between electrostatic and piezoelectric. So it's the same explanation is applicable to the magnetostriction also there. So when you go for magnetization of materials in which magnetostriction property is there, that is also behave in the same manner. So that is a difference between piezoelectricity. Your questions may be answered from this slide, how this can be employed for higher applications. So piezoelectricity with which there are materials which are coming under that class. Then the other material which has been classified in the electrostrictions can be applied for higher applications. So this is the next group of material, magnetostriction, in which it might have the similar characteristics is there. When you apply force or when you apply the magnetization, it will work for you the same manner how electrostatic material is working. But initially it has been thought that it will not be useful, since the giant magnetostriction material which has been found out, particularly this terphenol which has been mentioned here, it is an alloy of terbium and other material, maybe iron and other material is there, with which the material is playing a huge role in the room temperature itself. So that is what make this can be taken for the application. But one more deficiency with this non-negligible hysteresis, the complexity in its characteristics makes applied for directly for industrial applications. But if you go for a system kind of an arrangement like this, having a controller and a hysteresis compensator by having the linearity there, you'll be able to control this, and whatever the output requirement can be solved with this arrangement. So there is a need for a proper control system to have proper output outside. This has been already in place. So we'll be able to use magnetostrict materials for our use. This is one such example where you can see the suspended bridges in which cables have to be tested with. This is one material where it has been employed with its pile as well as external material, housing materials. Whenever there is a force which has been subjected to in the cable that has been transferred in the form of electric signals that can be captured, and it can be mapped with the original benchmark or whatever reference curves, and you can see that whether there is a change or not, like non-destructive testing is possible. So these are some examples. As you said, the applications are very little with piezoelectric. We can go with air applications for injecting nozzles, which has been used, or motor, or configurations like inchworm movement of robots, in which you can have the snake kind of movements will be possible with this. So this is another group of material. So you can, Nila, you can stop at any time because we told that 8 o'clock, no, another 10 minutes is there.
Okay, okay, sir. That John sir,
Yes,
sir, John sir, you can tell sir.
I am
Okay.
proceeding with another material. If it is okay, I can proceed.
okay, sir. Please proceed.
Okay, this is another interesting material called rheological materials. In the last 10 years, I could see that some of the research which has been done in Audi tank factories, in which suspensions mechanisms which were tried with this MR fluid. So a rheological nature of fluid is there. In addition to that, some of other characteristics can be built.
All watching this video.
I can skip one video which has been associated with this slide. We can go with some other video in between just to showcase what is the application of this. Okay. There are electrorheological as well as magnetorheological fluids in which the behavior can be made possible to have, no, it can be employed for some kind of applications in which the materials can be smartly behaved. Okay. This is electrorheological fluid. When the electric field is applied, so by having control over these materials, we can have different movements which has been possible. As we have seen the inchworm movement, similar to that here also in this material also it will be able to get it. So by applying and removing electric field, you will be able to align the arrangements as it has been mentioned earlier with electrostatic materials. So here, by having fluid, it consists as a medium which has been used here. So it needs some kind of processing to have the CIPs which has been in place to get it done with the materials to be magnetorheological arrangement. So these are some of the applications in which you'll be able to see that, particularly in case of is it visible? Video is visible?
No, sir.
Okay. Is that today it has been felt in Zoom? Is it like that or very rare used in Zoom?
Okay, okay, okay. Are you playing that video, sir, now?
Now I'm playing.
Ah, yes, sir. And now it's playing, sir.
We made venom. Oh shit, that's awesome.
Our project concerns the fabrication of magnetorheological fluids. Magnetorheological, magnet liquid. Such fluids are solutions of ferrous particles and a carrier solvent. When subjected to a magnetic field, MR fluids become less viscous and fluid than viscoelastic and solid. We added ferrous powder to various carrier fluids such as oil, oobleck, slime, water, and others. We were able to create tendrils of fluid by holding the magnet near the fluid and allowing the attraction to the magnet to pull the fluid up. The ferrous particles in the fluid aligned to create support for the tendril. After the removal of the magnet, the tendril only slowly flows back down, though the fluid shown is a very viscous fluid, slime. Polarity of the molecules to the carrier fluid also significantly impacted our results. The reason water sucks as a carrier fluid is that the random alignment of polar molecules can unalign the ferrous powder. That is why non-polar fluids such as soap and oil are better. Viscous fluids are better because if they are not viscous, then the ferrous powder will flow through the fluid rather than with the fluid. That will leave the ferrous powder basically on its own without having affected the carrier fluid, thus defeating the point of a magnetorheological fluid.
It's perfect. Is it 9? Is that slide visible?
Visible, sir.
Okay, so that is what has been employed. You can see in the prosthetic leg in which you can have some kind of suspension. It is required sock which will not move to the original leg of human. Likewise, armored devices, vehicles in which suspensions can be possible with this. So some of very good applications has been developed with this. It's a long research which has been going on. So this is another group of materials, thermo-responsive materials, in which the materials gets aligned with what is the temperature with which it has been experienced. So there are a group of materials which classified under this, where the miscibility cap on the temperature composition, which makes that these materials can work on this basis. Not all the materials work on the same temperature ranges. There are different temperature ranges in which these materials which will be given in the smart manner. So those materials can be identified and can be classified and under thermo-responsive material. And these are some applications in which you can employ this. You have health applications, as it has been mentioned on the other side. Drug delivery or sensors can be applied. On the other side, textiles, which this has been very well, which has been used. You might have seen that the thermal wears which has been used by people nowadays. So chromogenic material are the other materials, which is very well familiar with every one of you. Might have used in your sunglasses. That is working on this basis. There are 3 different group of materials are available under this: photochromic, thermochromic, and electrochromic materials. So based on whether light or temperature or electrical energy which has been employed for stimulating this material to act as the change in the color which has been taken. So photochromic we have seen in the sunglasses, which has been with when it has been exposed to the light, which has been changed its properties. Like thermochromic, you can see an example here, which will be used. In the hot to understand what is the what with which this material is exhibited. It might have in the experimentations it might have been used. you'll be able to see different colors based on what is the temperature with which it has been employed. So the same can be employed in the industrial applications where we wanted to identify what is the temperature at which it has been executed. So the thermography techniques which has been employed in industries can be very much useful to understand the material state at different temperatures. So that is one kind of application which can be possible with thermochromic. So this is another application. You can see that photo or thermo both can be employed in a smart house or hall in which the glasses which has been built can be employed, and you can see that bacterial antimicrobial effect will also be possible with this. So need not to have such kind of system to have clean all those things where the sunlight which will be able to go with. So you need not to close the door or open the door, and which you want to change the effect in a room. Nowadays, we can see that aircraft cabin windows, it will change so based on if you have simply switch on or switch off, whether there to apply the electricity there to electrochromic materials. It is you can see one more example of that which has been applied in Chrysler Pacifica, where the rear view mirror can be made to different state, so that the in the nights the blowing or reflections which has been coming there, that should not disturb the drivers. Yes. So the large number of applications are possible for these different chromic state materials, which can be employed in textiles also. So this is another group of materials. We hope I reach the time. If we need, I can go further, or otherwise we can stop here our discussions. If you wanted to have some discussion so far what we made delivered, and which we can have a discussion. Nila?
Sir, how much more is left, sir? There are so many slides.
Another 60 slides are there.
Okay.
Tolerances are there. Then we have now other materials, biomimetic materials are there.
Okay, sir. What is important?
Nearly halfway we are through now.
Okay, sir. You can cover some important materials alone, sir. Otherwise,
Okay.
Which will be in real-time application like that.
Okay.
Yes.
Yeah, all are real-time application only, but you can see that just we'll rush through this. Okay. This is
Yes,
one the important inventions where you can find that Nobel Prize winner, Ieirlc. His invention, but just because of that he got it. This has been manufactured, produced by having two carbon electrodes in which the fuller, the external structure which has been manufactured, which has been used switching devices and semiconductors. You can see the transistors in which it has been replaced, TFTs, which has been used. There are fullerene polymers which were used to solar cells, and there are fullerene free polymers which has been employed where solar cells which has been manufactured, which will having a real-time effect on its efficiency. That was the real invention which has been come out with these fullerences. There are other applications which has been mentioned on the other side. In the whether it is a paint and fire retardant materials, it becomes because of this, or medical applications, it can be extended. And biomimetic materials, you might have a large number of materials which has been there. In civil structures, might have employing this, having there were dust-free surfaces, self-healing surfaces, on which you might have used this. So the cracks cannot be proceeded further, kind of locking, self-locking mechanisms. Just by having impressive with the biosystems, in which it has been taken as the Sark skin on which how water repellence is there. The same can be used in windows where it might have, or in the building walls in which it might have water repellence is there. So we will be able to have kind of coatings which will be possible without disturbing visibilities. We can employ for next level applications also these kind of structures. This is one such structure which has been there in the bridges to avoid cracks there. These are all having impressed with the bio structure, which has been mimicked and formed these kind of structures. This is another important inventions where I might have seen the filtering ability have been improved with when you see the filters which has been employed now in the aqua cases, the aqua filters which has been used, the atomic level filtration which has been possible with. So this is another important material, safe memory alloy. Most of you know mechanical people might have very much aware of this. Nitinol is one such example. The group of alloys which has been used. Might have seen in our dental applications. We have used that to have alignment of teeth. So it is between the austenite and martensite change in structure because of the temperature effect. So it comes to the original structure after the stimuli is removed. That is used in different applications. When you have such kind of structure which has been used, you have a large number of applications. You can easily understood what is the effect of this on research. In 69, you can see how many number of papers, and in 19, so nearly 25,000 papers which are published in this field. That shows a large number of still people are working on this, having employed with different areas. So somewhat we are also tried with these alloys has been used with endoscopic applications. Or you can see in the stent how it can be used in blood vessels to expand. And large number of health sector, aerospace, and automotive applications. As you can see in our spectacles, it will not getting broken. You might have it comes no. It is not being very easily damaged with other materials when it is used. So this is another important materials where whether it is insulator or conductor based on what is the force which has been applied there. So quantum tunneling composite, it is very important concept of quantum physics in which you might have seen photons and electrons when it is subjected to giving proper kinetic energy, it can cross the barrier. The similar kind of things can be employed, having structure which has been formed like this, spiking structures. To be able to have this having considered when it is having external press or force, there it will act as a conductor. It's actually insulating material which will act as a conductor there, so that you will be able to having switching like this. So now because of this, what are the applications you might have find? And you can see that in your cloth itself might have used switches. There you can switch on, switch off, or some kind of remote controls you will be having with your cloth is possible. A conductive cloth, or you might have embed devices, electronic devices there in your cloth itself. It may be a high-tech, smart dresses, textile materials, which will be possible having embedded these kind of quantum tunneling composites. This is another important material. There were a large number of inventions and different sectors other than textile also. It has been there in the computerization where the soft keypads will also be possible. Leading textiles. So in the conclusion, we have a large number of these materials which will behave very smartly. If one can have greater imaginary power and match with applications, they can try to implement the characteristics can be matched with the requirements. match with complete ASIA systems with the other elements which are required for that. Maybe you can have a proper smart system in your hand by applying these materials. So I hope I have just justified their expectation as well as the time limitations which has been given to them. Thank
Yes,
you
sir.
very much. If you have any clarifications, if you are able to answer, I will be able to do that. Otherwise, I will contact you through mail.
I request
Sir,
all the participants to get clarified whatever doubts they have.
Sir, one doubt I have regarding this.
Yes,
Sir, this shape memory alloys, no sir, like this metallic shape memory alloys, no sir.
Yes,
Can we
sir.
use it for some wear applications, sir, where this because of this movement that wear can be controlled like that? Anywhere you have heard in your experience?
No, I didn't seen any application on the VR side
Okay, sir.
because it is of no in the robotics I have seen some of the applications because in the end the grippers
Okay, sir.
where we be able to go for applications. I don't know that VR applications will it be employed or not because
Okay.
the concept is entirely different from this.
Okay, sir. This is generally like I'm assuming by myself because a static material and there will be a fluid which is contacting this thing. This is a static
Okay.
material. Instead of a static material, if there is a shape memory alloy, will it reduce wear? This is my like general
No, if
imagination.
it is three-dimensional, that is okay. If it
Okay.
is on shape changes which has been occurred, might
3D
be
only, sir. Pipeline or some duct where we pass our flue gas with particles.
maybe you can try some kind of applications. I didn't know seen that kind of applications has been used.
Okay, sir. Okay, sir. Okay. Any other doubts anyone has can ask?
Yes.
Sir, sir, just one thing I try to know, sir, that
Yeah.
this type of materials are used in wearables such as smartwatch and all you have told.
Yeah.
But I want to know in the health perspective, sir, how safe it is with respect to health when it is concerned. Means wearing of a wearing of a smartwatch for longer time, whether it will impact anything in the health. This thing I want to know, sir. In
No,
that,
the
if you can.
material, if it is not radiative, it will not be harm anything to the health. It is just a mechanical action with which if it is function, then it will be okay. Any material which is radiating, which may affect our body conditions, that it may be harm to the health.
This
I don't
piezoelectric
think that the
do not
material
radiate
itself.
any this thing, sir.
Ieirlc,
Any
Hello, one more question, sir.
Yeah, please.
Yes, Mani
Sir,
wanted to
this
talk.
safe memory alloys you are telling, whether India anybody is manufacturing for teeth alignment and all.
Yeah, in India, I tried to actually Medal, they requested for us to go for these kind of endoscopic applications in which there are no, I found that it is completely imported. India is still zero, I think, the material
Yeah.
side. Most of the
Okay.
materials, mostly on Chinese, are dominating.
Yeah, Korea also it is got,
Yeah,
then
Korea.
US also it is imported. Whether any efforts are made for manufacturing in India?
So far, I don't know that to my little knowledge. We are also trying that, but we failed.
Oh. Okay. Whether any research
But
is
it
still
is very,
going on,
very
sir?
great requirement is there. If anybody is working on this field, they may convert that into a great commercial applications. With large number of requirement, not only teeth alignment. It is for endoscopy or stent, where you can have expansion and contraction the material. Naturally, it will fit with the human system.
Oh. Okay, sir. I will get in touch with you. We'll
Thank you.
discuss.
Sure.
Thank you, sir. Thank you.
Any other people?
so this piezoelectric materials are not radiative, no sir?
Not ready.
Okay, sir.
Dr. Kumar?
Sir, no, sir. Thank you.
Engineer T. Armugam.
I hope I have delivered something to you, or is there? It is very little information already. You know.
No, sir. Some topics were many things were totally new to us, sir. We will now.
Actually, I have rushed up all those slides at the second part of our discussion.
Okay.
That is
Okay.
also having a lot of interest on that. One can.
No, at least
do a lot of-
hereafter, sir, if we see these things, we will at least identify, sir. Maybe we were
Yeah.
not knowing these things earlier. Except shape memory alloys, we were not aware of all these things.
Okay.
And I would request you to come for a virtual presentation to us,
Okay.
to Ranipet, so that you can take your own time, straightly explaining the everything.
Okay, sir.
Almost 88 slides you have, some videos are there, but
Yeah.
everything we.
I didn't play some of the videos. I have skipped.
Yes, that's what I'm telling. Today, because of the time restrictions, I think 1.5 to 2 hours is required for your presentation. I think that can be organized at our center at Ranipet or somewhere here.
Okay, sure. Sir.
I think in a short period we'll try to mobilize that.
Okay, sure.
Anybody else is having any doubt or any queries you can arise? Otherwise, I request Ganesh Babu, our honorary secretary, to explain the presentation as well as the thanking the faculty and all the participants. Ganesh Babu, I think SS Mani is having again some doubts. Sir, please. SS Mani, please. Ganesh Babu. You can proceed.
No, you want anything to be told?
No, you are raising hands.
No, I already asked Professor the question. He has answered also.
Okay. You are asked, but still raising hands
no.
are there. That is the reason I thought you have further queries.
No
Okay,
issue.
you might have raised
Thank you so
long
much.
back. Okay.
Thank you so much, Professor. Thanks a lot.
So thank you very much for the opportunity, sir. It is my great honor for being such a light group for which I made some presentations. I hope that it has been reached you in the planned manner. Okay. I hope that some time will be there to reach directly there,
Yes.
and interact with you. Thank you for the opportunity.
Okay. Ganesh Babu.
So good evening, everyone.
Good evening.
Very special thanks to Capt.Dr.A. Suresh Babu sir, Professor, College of Engineering, Guindy, Anna University, Chennai, for showing very keen interest to give us introduction about the smart materials subject to almost all of us. And sir has taken very good interest, enthusiastically explained us the insights of the smart materials, along with the reference books we disclosed. Started with definition of smart materials, their need, smart and intelligent structures, stimuli, components of smart systems, classification, piezoelectric effects, and especially a lengthy topic on group of smart materials and piezoelectric materials, application of piezoelectric actuators and others group of materials, mechanisms, rheological materials, etc. And sir, sir made this presentation very interesting by making animated and interactive videos to visualize the process. Even though we are attending online, it has given a feeling of physical presence of the lecture session. Sir, thank you very much, sir. And the end of the session, the question and answers are there. That means members have been involved, and sir is able to success in involving the members who are participants in his presentation. And thank you, sir. Thank you. Also, I thank Sri John, sir, Chairman, Ranipet Local Center, for having interacted and coordinated this session. A very special thanks to Neela Madam for introducing such a knowledgeable professor to the community of Institution of Engineers India, Ranipet Local Center. No, last but not the least, I thank each and every member for the joining and patient listening. And also I thank Tamil Nadu State Center for facilitating this online platform to make this program success. And having successfully conducted this program, and we cordially invite Capt.Dr. Suresh Babu sir to have a visit so that we can personally have interaction and will gain more knowledge from his subject. Thank you, sir. Thank you very much.
Sir, I would also like to add to Ganesh Babu
Oh.
sir. Immediately when I asked, sir accepted. Thank you so much for your time, sir. In midst of your busy schedule, you have spared time to us, and you didn't take any time to accept the request. You just said okay. So
Just
thanks
for
a lot.
Neela.
Yes,
Neela,
sir.
you are very important to me. You are a long association.
Thank you so much.
One of the
Sir. Thank you.
student having since these many years. It is
Thank
very rare. Na?
Yes, sir. Thank you so much, sir. Thank you.
Convey my queries to her husband and children.
Sure, sir. Sure, sir. Thank you, sir.
Once again, we extend our warm thanks to you, sir, for having accepted within a start notice and spare your time in the evenings and explain to us about the smart materials. It's all new to us. That is great. And we also thank the state center, especially the Madam Rati, who is still available at the headquarters to help us. So I thank the TNSC State Center, the chairman as well as the honorary secretary, as well as all the office staff, especially Madam Rati also. Thank you so much to everyone. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.